So it's a first very simple experiment on range, okay? But now we're going to attack a very serious, but still fun, but very serious topic, the antenna. I'm calling it princess antenna because you have to respect her. It's the most important device in your life, at least at Sigfox. So, going back to some very basic of propagation. Because you have a propagation and because it has been created by a somehow sinusoidal electrical generator, so I cannot use the antenna now. Because this is the time domain waveform of your transmitter, and because though this is creating vibration over the magnetic and electric fields, and this is propagating over the air, well, there is indeed a spatial periodicity in the propagation. So basically, this movement of electrical charges is being copied by the fields. So basically, you take one point, take this point. Well, this point is oscillating at the rhythm of the, in that case, magnetic field. Okay, could take electric. So electric is this. Well, in fact, it's this. Okay. Okay. But you see that it creates, because of the speed of the wave, which is traveling over the air or over the space, it's creating what we call a spatial periodicity. And this spatial periodicity is referred as the wavelength of the transmission. And in fact, the wavelength is calculated this way. Wavelength equal speed within the medium, which in that case is c, the speed of light, divided by the frequency. So the greater is the frequency, the smaller is the wavelength, which is normal because the speed is constant, and if the vibration is very fast, the periodicity is very small. If the frequency is very, very low, very, very slow, you have time to travel a lot during a period. Okay? So basically, if your electromagnetic field is vibrating at 1 Hertz, which is possible it's maybe not possible on Earth to make a transmitter at 1 Hertz, but in the sky, in the universe, it happens. Okay? So if you consider an electromagnetic wave at 1 Hertz of frequency, in fact, during 1 Hertz, your wave is traveling 300,000 kilometers. So your wavelength is 300,000 kilometers. Okay? So in fact, because of this spatial periodicity, there is a great chance that, in fact, the stuff which is creating the wave has to be in relation with the wavelength. And in this animation, which is quite good, you see the electrons which are being moved by the generator. This is the generator, so the electrical pulsing machine, which is pulsing the electrons in opposite phase on the two conductors, this being the dipole. By the way, when you consider a line, a power line, there is no propagation because the electrons are doing this. In the 2 or 3 wires, if there are 3 wires, but let's simplify. If there are 2 wires, it's a biphase system. The electrons are doing this. Okay, so it's not radiating. This part is not radiating because electrons are going in the opposite direction each time. So in that case, you cancel the propagation of electromagnetic waves. But you would do that, it would propagate. So you would have whatever thousands of kilometers of power lines being supplied by the 50 Hertz generator, it would radiate, for sure. Okay? It's not radiating because it's doing this. So this part is not radiating, but this part is different. This part is radiating with very simple assumptions, which are that here you cannot have any current. You don't have any material to conduct electrons, to conduct the charge. So here the current is always null. But the voltage can be at the maximum. And this maximum is following the pulse of the electrons. As you want to have a null current here, in any case you will have a null current, but you want this null current to be in phase somehow with the maximum voltage. So you need to respect length compared to the wavelength. So that's why it is called the half wave dipole, because this is a quarter wave. This is a quarter wave. You have a double wave. So this is one of the most simple antenna. There are much, much more complex antenna, but in any case, those antenna have to be tuned to be in resonance with the pulsing current. That's what we call the resonance. So an antenna has to be in resonance. If it's not in resonance, it's not that it's not working, but it's very badly working. Even if the antenna is very small compared to the wavelengths, there will be some drawbacks. We'll come back on that. But even if it's very small, there is something so that it's resonating. If you want to optimize it as much as possible, it has to resonate. If it does not resonate, you will have some radiation, but very, very small radiation as to compare to what you could do with a resonant antenna. Well, I'm not maybe going to spend too much time on that, although I might do it because I'm filmed, so this presentation is going to be spread over the company. So maybe I'm going to spend some time. That's what you need to keep in mind with antennas. First, the antenna is the fundamental device in a radio system because it's the device which is transforming electrical energy into electromagnetic energy. And if you want to transmit a signal, you need this electromagnetic energy to be radiated. So you need a device which is transforming electricity into electromagnetics. And vice versa, at the reception, you need a device which is transforming the incident electromagnetic wave into electricity so that you can process and treat this electricity to extract whatever form of message or information which is comprised in the wave. It's also important to keep in mind that the behavior of an antenna is fully reciprocal. The performance at transmission is the performance at reception. If your antenna is bad at transmission, it will be bad, as equally bad in reception. There is no difference, absolutely no difference. Some people are saying, no, it's less important in reception, the antenna is less important. Well, no, it's not true. It might be less important in some case if you have high impedance receiver, and in some case you might exploit the electrical field, blah 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 blah. But in practice, no, it's absolutely wrong. If it's bad in transmission, it will be bad in reception, vice versa. So at the end of the day, once again, it's the most important part of a radio system. This has to be extremely important to understand. Whatever electronic or whatever system you might use to produce or receive wave is just at the service of the antenna, nothing more. I would not say it's a gadget, but almost. So we are going to continue the experiment. Back to the receiver. We are still tuned, yes. We've seen that using my finger, using my finger could be a way of, we are going to accelerate a little bit the reception. Maybe a little bit faster. Reducing the averaging. You still see the signal, which is, by the way, over there, but we don't see it because the bandwidth is a little bit greater than this one. But that's the magnifier of the signal, and we see it. Okay. Yes, if I'm putting my finger, it might, maybe, not sure. It might improve a little bit the signal. I'm not even sure. Is that my signal? Yes, it is. Okay, it's increasing, but it's not high power. Can we improve that? We can try various lengths. Okay, you see that it's improving a little bit. By the way, what is the wavelength at 77 megahertz? You take your calculator, but it's the 4 meter band. We are within the 4 meter band. Okay, 100 megahertz is 3 meter. 50 megahertz would be 6 meter, and 77 is the range of 4 meter. So basically, a quarter wave would be 1 meter. Okay, we are far from 1 meter. Maybe we can approach the 1 meter. And what we are going to do, we are going to increase a little bit the power. Why? Because now we are going to make the experiment at the opposite of the room, so that we are not too close to the receiver. Because being too close, we are not really having electromagnetic waves. I was discussing previously that when you are close to a transmitter, you are more in the condition of evanescent wave. So it's not exactly the electromagnetic condition. So we are going to put the transmitter a little bit far. So to do that, I need to increase a little bit the power. Okay? It should be sufficient. So back to the small, into bracket, the small antenna. And somebody is going to operate the transmitter. Ivana, you want to do it? Okay. So you put it on the table at the rear. Okay, and you try to be as static as possible. Try not moving too much around the transmitter. So you see, we receive the signal. We can say that we see the signal. It's not a strong signal. So once again, if I'm going back to FM, for instance, I still have a lot of noise in my reception. So a walkie-talkie, for instance, a small FM walkie-talkie, would not be able to exploit this signal. No way. Okay? Good. Fair enough. But once again, a narrowband receiver, and that's what Sigfox is doing, by the way. A narrowband receiver would be able to do something with it. And in that condition, by the way, we would probably be able to decode a Sigfox signal. And by the way, once again, we can put some focus on it by narrowing the receiver. Well, it's still not very strong, but at least we see it. I'm hearing it, but it's quite difficult to hear it. You need to have your ear trained for that. By the way, it might be better depending on how your ear and how your brain is working. Might be a little bit better depending on the frequency. For me, it's better there. Here it's for my ear and my brain. It's not the best situation. So I'm better when. Oh, I'm going too far. I feel better personally for me. That's the optimum. I don't know if it's the same for you, but for me that's the optimum. That's where I'm able to notice very well the signal. Indeed, I can do, once again, I can use signal processing. In that case, it's easy to hear, okay? And it's really my signal, huh? Okay. So what we are going to do, Ivana, please, can you extend a little bit the antenna? Keeping the transmitter at the exact same position, but you increase by one element. You see, by the way, the body effect of Ivana. So it's a little bit stronger. Indeed, it's even stronger when she's putting her hand on the antenna. But now extend a little bit more. Okay. Remove your hand. We've gained some dBs. Okay. So we are now at this position. I'm keeping the mouse on it. Please double the size, approximately. We've probably gained 3-4 dB. Now maximum length. Yeah, that's okay. It's okay. We have gained 1 or 2 dB, 1 or 2 additional dB. Now the signal is quite easy to hear. Okay, is that sufficient to listen to FM? No. But listen about it and compare this to this. We start to have a first beginning of service in FM, what we call the kieting. So in FM, you want this big noise to be minimized. And that's what you call the minimum service. The minimum service is when the clicks are very rare in the noise. They are still easy at this time, but we start to hear a difference between outside the signal, once again, and within the signal. But it's not enough. So we're going to try to do better. So to do better, we are going to do this. I need to go back on the slides. We're going to do this. In fact, on the board, I have, here it is. On the board, I have those two elements. We can switch from a direct path. So far, we had a direct connection from here to here. And now we are going to insert those two components. Basically, fundamentally, those two components are equivalent to a coil, which is trimmable. So it's like if I had a coil that I could adjust. So I could add wire or subtract wire. But to do this more practically, instead of using a trimmable coil, I'm using a big coil which is trimmed with the counter component, which is the cap. So the cap, when you reduce the cap, you reduce the coil, and when you increase the cap, you increase the coil. It's equivalent. Okay. So you have to consider that it would be as having a trimmable coil. So back on the receiver, back on this kind of demodulator, so that at least we can see the signal. Ivana, you are going to be my tuner. I have to show you. I have to show you anyway. You're going to gently and very slowly trim, and we're going to use a given lens, for instance, a lens like this, which is not, as you can see, which is not a quarter wave, because it's smaller than a quarter wave. It's probably half of a quarter wave, so an eighth of wave somehow. We put it again on this location, and with the side of the screwdriver, you put it here, and you're gonna turn it very slowly, but I first need go through the tuning device. I call it the tuning device, and it might already be better. Yes, it is. Yes, it is much better, as you can see, even without tuning. But you're gonna tune anyway, so you're gonna turn it slowly. So there is a lot of spurious, sorry, on the transmitter, because once again, it's a quick and dirty transmitter. So you turn it. So you can see the signal is, you can see here or here. You see that the signal is evolving, increasing, decreasing, etc. So she's really tuning the antenna. Try to tune to the maximum. Yes, here you are. But a little bit before. Go back. Stop. There is a certain delay, so you have to be very, very, very slow. Well, let's say it's not bad. You've seen the difference, however, you've seen the difference without tuning device, and with the tuning device. It's a huge difference. We've gained, I don't know, probably 20 dB. Maybe more, I don't know. At least we've been winning a bunch of dB, okay? Now, it's okay, you can stop. Now, can we have FM service? By the way, all those spurious are the 50 hertz spurious, so we probably have a power line somewhere which is disturbing the transmitter. But anyway, it's not a big issue. So we go to FM, and except that we have some hum at 50 hertz, except the hum, yes, we have getting, and you can hear about it. You hear the hum, which is the 50 hertz noise, but at least you no longer have any, it's like a kind of modulation, but you no longer have any phase click. There is no longer noise. It's almost quiet, except this 50 hertz and 100 hertz noise. It's almost quiet. So we came from a situation where we were really only detecting the presence of the signal in FM mode to a situation where we are in the quiet, what we call the quiet condition. So basically gaining 20 dB or more just by tuning the antenna. Okay? What else can we do? Yes, we can probably, it's going to be maybe a little bit difficult, and maybe I have to go back here, reducing the power. Now we are going to look at the influence of the environment. I'm going to, with a certain length of antenna, I'm going to try to find my maximum. So I'm looking at the monitoring, at the RSSI monitoring device. For this antenna length, seems that the maximum is there. Okay? It's maybe a little bit less optimized than if I would do this and retune the tuner of the antenna. It's already a little bit better, so even fine-tuning a little bit more, it's better. Because there is no miracle. The more you approach the quarter wave, the better it is. So let's go back to something like this. Retune it. Here it is. And now I'm going to use this piece of metal. Not putting it here because indeed it's attenuating the signal. Why? Because I am masking the antenna, the two antenna, but putting my piece of metal there. You might think that I'm improving the antenna because I'm putting a reflector behind the antenna. So you might say it's going to be better. But in fact, as you can see, it's reducing the power. Not so much, but it's slightly reducing the power. Okay? I'm going to try to retune the antenna. So just finding the... So you see it, huh? There is a detuning because of the piece of metal. Can I retune my antenna? Yes, I can do it, but it's not... I'm detuning and I'm retuning a little bit. It's not so flagrant. But so to say that the environment has a big influence on the antenna. So I might have a well-tuned antenna. Okay. If I'm changing the environment, I might have some trouble. Maybe I can retune it a little bit. Maybe I miss one extra component. Probably I miss a cap here in parallel to retune the system. So it's difficult to retune it optimally. But for sure, I'm degrading. So you also need to keep in mind that even though a device might be well-tuned, it might not be well-tuned in the environment. When you take your phone is supposed to work well like this. If you put it on a car, 20 dB less efficiency.